So our next section that we're going to cover in this book, which is Chapter 4, Lesson 2, deals with the different forms of energy that we use on a regular basis. Now in 6th grade we don't cover all the different forms of energy, but these are going to be the most common ones. The first, we need to understand the idea of mechanical energy, and when 6th graders start reading about this, they just automatically get to the idea of mechanical and understand what mechanical is, and they have the idea of mechanical means machine. And so we've talked about the turbines in the wind energy and the water energy, or different types of machines or sewing machines, right? So different types of machines, they are indeed mechanical. You could even talk about the Rube Goldberg machines, which is where they take a whole bunch of different normal everyday things and have one reaction to another reaction to have a very simple outcome, such as this one where it turns on the light. Or one of my favorite movies is Chitty Chitty Bang Bang, and the inventor in that movie, he has a Rube Goldberg machine that helps him make his breakfast. But that's not what we're talking about when it comes to mechanical energy. Mechanical energy combines two different types of energy that we just talked about in the last section. So it's when we're talking about motion mixed with position and shape. So if you'll recall from Chapter 4, Lesson 1, motion was kinetic energy, position and shape dealt with potential energy. So when I mix those two together, then I get mechanical energy, both of them working together. For example, when I look at this individual and he sees a sledgehammer and he needs to drive that nail into that block of wood, then the potential energy is sitting inside of that sledgehammer on the ground. The kinetic energy is when he lifts it up into the air, and then because he's lifted that large item, its position and shape, it has a larger gravitational potential energy up in the air, and then he swings it down. So he applies a force. So then we have kinetic energy again. So that entire system of motion, combining all the kinetic and the potential energy together, is what we call mechanical energy. Or if we look at the idea of shooting a bow and arrow, when I pull back the bow, I have potential energy. Now, the potential energy also came from inside of me because I ate some food and I created ATP and I had the energy to pull back the bow. So that energy was used as well. I moved the bow, but as long as I don't let go, then it's just going to be held there for as potential energy. But when I let go, then it shifts from potential into kinetic. All of those things working together then, from pulling back the bow, releasing, the arrow flying, then that would be considered mechanical. Or for those of you that are sports fan, it's the idea of being able to do work, right? So shooting a basketball, we don't think of that as being mechanical energy, but it absolutely is, right? Inside your body is the stored ATP and chemical energy as in potential form. You go to shoot it, and as long as that basketball is in your hand, it's just potential energy. But once you force it, you throw it up into the air, then you have kinetic energy. It lifts up into the air and it's going to be up above the rim, and that's going to be gravitational potential energy until it goes inside the hoop, and then it's going to be kinetic energy as it goes down. So mechanical energy is the combining of kinetic and potential together to get some work done. Other types of energy then is when we start looking at the particles that are inside of objects. When we talked about particles, we talk about atoms and molecules. So the ones we're going to look at is nuclear, thermal, electrical, electromagnetic, and chemical. So be sure you're taking your notes inside your book, highlighting, writing them down. It'll help you with your assignment as I go through these. So once again, when we talk about particles, we're talking about atoms and we're talking about molecules. And when we talk about atoms, we're talking about all the different elements that everything that we know of on our planet is made up of. All the way from the smallest atom, which is hydrogen, and then the second smallest is helium, up until the very large ones. And so far, everything that we know is either a solid, liquid, or gas. So when we look at all of those different things, sometimes we combine things. So if I took hydrogen and I mixed it with number 8, oxygen, and I force them together, then I end up with a molecule. So atoms, once again, are made up of different parts. In the center, it has a nucleus, kind of like the nucleus of a cell. It's in the center, and it controls it. But the nucleus of an atom has protons and neutrons. Protons are positive. Neutrons are negative. They don't have a charge. They just connect to the protons. On the outside, kind of like in the orbits of moons around the planets or the planets around the sun, are all these electrons, and they're negative charged and they're spinning around. So electrons are going to be attracted to other electrons to make some balances. But when I look at the idea of taking two hydrogen atoms and one oxygen atom, and I'm going to force them together to make one thing, that's when I get a molecule, and that would be a molecule of water. So individual atoms are particles, but then when I force them together to make something different, right? Two hydrogen and one oxygen, two very different things, but when they join together and make a substance, then that is a molecule. So when we talk about these other forms of energy, then we have to think about how they're made up. So one is nuclear energy, which we talked about earlier when we talked about the sun in our very first book. So nuclear energy happens in the nucleus, and that's one of the ways you can remember. Nuclear and nucleus have the same root word, which is nuclei. Okay, so inside of the nucleus, we either can split the nucleus, so we can take it and we can pull apart the neutrons and the protons. And when we do that, we get nuclear fission. It's going to pull apart, it's going to give an explosion, and it's going to give us a whole lot of electricity. The other side to that is forcing them together. We're going to fuse them together. And that's what happens inside of the sun. And that goes back to our very first book. When we have all of these hydrogen atoms and they're being forced together and they end up making helium because of the great gravitational force inside the sun, it's making these constant explosions. And that's nuclear fusion. It doesn't give us electricity, but it does give us two other forms of energy. It gives us heat and it gives us, we'll talk about both of those. So when I talk about thermal energy, that's one of them. That's our heat. So when it comes to thermal energy, the book tells us it's the total of kinetic and potential energy combined inside of the particles or inside of the atoms and inside of the molecules. Meaning that if I pull them apart, if I break them apart or force them together, how much heat am I going to give off? But if I just remember that thermal energy is heat, it's a little easier to understand. It's kind of like the idea of, a boiling pot of water. I'm applying heat to the pot and I'm boiling the water, and the water is breaking the molecules apart because of the heat, and it's going to split it into smaller particles where I end up with water vapor. When I burn wood, I'm applying heat to it, and therefore it's going to break and it's going to change that wood into some different particles like carbon and light and heat. So it's the thermal energy is the heat aspect. Or I can change electricity with a heater, a space heater, into thermal energy. When it comes to energy and heat, then what we talk about is when the temperature is lower, then I have a smaller amount of thermal energy. When the temperature is higher, then I have a greater amount of thermal energy. But there's always thermal energy. It's just, is it really going to be low and you need a coat, or is it going to be hot and you need shorts? When I go to electrical energy, then it comes in a couple of different forms. I can either have stored chemical energy, which we call stored potential chemical energy. I can have potential and flowing kinetic energy, which we call electricity. Or I can have static electricity, all of which are electrical energy. Right? So the idea of the stored would be like batteries. We understand batteries store energy. Some of them are chargeable and rechargeable, and some of them you use them and you end up having to throw them away. Static electricity, we've all done that. We've rubbed our socks on the carpet and then went and touched somebody's ear or a doorknob, or not even intentionally, we touch something metal, all of a sudden it shocks us, right? Or we've seen lightning, and lightning is like the biggest form of static electricity that we see in nature. And then we just have flowing electricity, which is that middle one. It has potential and flowing or kinetic electricity within its circuit itself. So when I look at the electrical charges, then we're talking about positive and negative, just like the atoms do. So in electrical charges, I always have positive and I always have negative, and they're always pulling towards each other. It's kind of like when I look at a magnet, right? If I push north and north together on a magnet, they push each other away. They do what we call repelling. If I have a north and a south of a magnet, they're attracting each other, right? So if I have electricity and I have positive and positive, they don't like each other. But positive and negative really like each other, and they allow electricity to flow. So when I put batteries into a flashlight and I have them lined up correctly from positive to negative to positive and negative, and then I have the connector pieces, it allows electricity to flow and turn on the light. In our bodies are most generally a positive charge of atoms. But a lot of metals around us end up building up negative charges. And when they have a really high negative charge and we touch them, snap, you get a little bit of a shock. On the ground, we have a buildup of a lot of positive electricity, positive charges, and in the sky, especially when there's storms, it's going to be mixing around and it's going to build more and more and more negative charges. And when they connect, you have the exchange of electricity, and that's what lightning is. When I look at light switches, when I think of the potential, so as long as the light switch is off, then electricity isn't flowing. But once it flows, then I've got those negative charges that are going to flow, and they're going to change, and they're going to be drawn back to the positive end of the light switch. And the goal is that as long as the light bulb works, it's going to light up that light bulb, and I can show that the energy is flowing. If I want the energy to stop flowing, I simply turn the switch down, and electricity stops flowing. Then we get into electromagnetic energy. So electromagnetic energy is what we just simply call light, but there are so many different levels of light, and we just get introduced in 6th grade to 7 different ones. So when I look at the light spectrum, there are so many different ones, and if you get into like physics or a higher class of science, then you'll study more of these different levels. But when we think about light, we think about just visible light, but there are several different other categories of light, and the other categories are what are invisible to us, but we can see their effects or we can use them. But light travels in waves, just like sound travels in waves. And so the waves is what carries light, and the frequency, if the waves are closer together, more compacted, the stronger the wave of light is. The further out, like over to the right, the weaker the light is. So when I look at our common light, the ones that we're introduced to, there are 7 different ones. We go from the weaker light categories to the stronger light categories. Our first one is radio waves, and they carry exactly what they sound like. They carry the sound waves of radio, but they're carried through light waves from, a transmitter to a receiver. So they're broadcasted from the radio station, and they're picked up by our cars or by our homes or by, our radios. Then we go to microwaves, and that's exactly how the word microwaves came about, because they use the somewhat weak level of light known as a microwave. And then we get into infrared, and that's what some police officers or scientists will use in order to see heat. So when we talk about using like heat goggles or something like that, then they're using infrared. They're picking up heat indicators that don't really need outside light in order to be seen. Then we get into our visible light, and that's what we see on a regular basis when we turn on our light switches in our classrooms, in our bedrooms, or we go outside and the sun is shining. Then we get into the more intense lights. So the next and most intense light is ultraviolet light, and ultraviolet light is the #1 cause of skin cancer. And the best way to protect ourselves, and a lot of us, and I will tell you, when I was your age, I also did not use it, but sunscreen is the #1 prevention of skin cancer. And if you use it, you're much more likely to not have to suffer from it and get treatments when you're in an older age. More intense than that is X-rays, and X-rays are the light waves that they send through your body, and they'll pass through soft tissue and stick to hard tissue. So they will indicate broken bones or dislocations or fractures in your bones. And then the highest wave of light that we talk about are gamma rays. And that's what, if you are suffering with cancer, or you know somebody that has had cancer, you might hear them talking about how they go through gamma treatment or radiation treatment. They use gamma rays to try to kill those cells. It's a very highly compacted form of light, and they focus it specifically on the cancer cells themselves. Then we get into chemical energy, and this is where we finish up with our 6th grade introduction to energy. So chemical energy is found in all sorts of different things. We don't think about matches as being chemical energy, but this substance at the end of that match, as long as you rub it with friction, it lights, right? And it's that friction that heats up so quickly that causes the fire to happen and change its form. When I look at food, food has all sorts of stored energy. So we've talked about this in 2 different books when we talked about life and classification of life. So we know that we have consumers, and consumers have photosynthesis, and they take the sun's light, right? So the electromagnetic light, and they change it into glucose, right? So their byproduct is glucose and oxygen that we breathe, but the glucose is their energy in order for them to survive. And then the consumers come along and they eat the plants, and then some consumers eat them, right? Or some consumers will eat other consumers or eat the plants. But it's the eating of the producers that then give us the next form of chemical energy, and that's what we call ATP. That's the stored energy inside of our bodies. As we saw in the Bill Nye video, 60% of that energy is what's going to keep us warm, and the rest of it is what's going to keep our heart beating and our brains functioning and our lungs breathing. So that is all. Make sure you have taken your notes and rewatch this as many times as you need.